In photography and cinematography, a telephoto lens is a specific type of a long-focus lens in which the physical length of the lens is shorter than the focal length. This is achieved by incorporating a special lens group known as a telephoto group that extends the light path to create a long-focus lens in a much shorter overall design. The angle of view and other effects of long-focus lenses are the same for telephoto lenses of the same specified focal length. Long focal length lenses are often informally referred to as telephoto lenses, although this is technically incorrect. A telephoto lens specifically incorporates the telephoto group. Telephoto lenses are sometimes broken into the further subtypes of medium telephoto, lenses covering between a 30° and 10° field of view, and super telephoto, lenses covering between 8° through less than 1° field of view. Construction. In contrast to a telephoto lens, for any given focal length a simple lens of non-telephoto design is constructed from one lens. To focus on an object at infinity, the distance from this single lens to focal plane of the camera has to be adjusted to this focal length. For example, given a focal length of 500 mm, the distance between lens and focal plane is 500 mm. The farther the focal length is increased, the more the physical length of such a simple lens makes it unwieldy. But such simple lenses are not telephoto lenses, no matter how extreme the focal length they are known as long-focus lenses. While the optical center of a simple lens is within the construction, the telephoto lens moves the optical center in front of the construction. A telephoto lens works by having the outermost element of a much shorter focal length than the equivalent long-focus lens and then incorporating a second set of elements close to the film or sensor plane that extend the cone of light so that it appears to have come from a lens of much greater focal length. The basic construction of a telephoto lens consists of front lens elements that, as a group, have a positive focus. The focal length of this group is shorter than the effective focal length of the lens. The converging rays from this group are intercepted by the rear lens group, sometimes called the telephoto group, which has a negative focus. The simplest telephoto designs could consist of one element in each group, but in practice, more than one element is used in each group to correct for various aberrations. The combination of these two groups produces a lens assembly that is physically shorter than a long-focus lens producing the same image size. This same property is achieved in camera lenses that combined mirrors with lenses. These designs called catadioptric, reflex, or mirror lenses have a curved mirror as the primary objective with some form of negative lens in front of the mirror to correct optical aberrations. They also use a curved secondary mirror to relay the image that extends the light cone the same way the negative lens telephoto group does. The mirrors also fold the light path. This makes them much shorter, lighter, and cheaper than an all-refractive lens, but at the cost of some optical compromises due to aberrations caused by the central obstruction from the secondary mirror. The heaviest non-catadioptric telephoto lens for civilian use was made by Carl Zeiss and has a focal length of 1700 mm with a maximum aperture of f/4, implying a 425 mm entrance pupil. It is designed for use with a medium-format Hasselblad 203 Fe camera and weighs 256 kg. Retrofocus lenses. Inverting the telephoto configuration, employing one or more negative lens groups in front of a positive lens group, creates a wide-angle lens with an increased back focal distance. These are called retrofocus lenses or inverted telephotos, which have greater clearance from the rear element to the film plane than their focal length would permit with a conventional wide-angle lens optical design. This allows for greater clearance for other optical or mechanical parts such as the mirror parts in a single-lens reflex camera. Zoom lenses that are telephotos at one extreme of the zoom range and retrofocus at the other are now common. History. The concept of the telephoto lens, in reflecting form, was first described by Johannes Kepler in his Dioptrice of 1611, and reinvented by Peter Barlow in 1834. Histories of photography usually credit Thomas Rudolphus Domia with the invention of the photographic telephoto lens in 1891, though it was independently invented by others about the same time. Some credit his father John Henry Domia in 1860. In 1883 or 1884, New Zealand photographer Alexander McKay discovered he could create a much more manageable long-focus lens by combining a shorter focal length telescope objective lens with negative lenses and other optical parts from opera glasses to modify the light cone. Some of his photographs are preserved in the holdings of the Turnbull Library in Wellington, and two of these can be unequivocally dated as having been taken during May 1886. One of McKay's unregistered trademark S photographs shows the Russian warship Vestnik anchored in Wellington Harbour about 2.5 kilometers away, with its rigging lines and gun ports clearly visible. The other, taken from the same point, is of a local hotel, the Shepherd's Arms, about 100 meters distant from the camera. The masts of the Vestnik are visible in the background. McKay's other photographic achievements include photomicrographs, and AA shadowless technique unregistered trademark for photographing fossils. McKay presented his work to the Wellington Philosophical Society in 1890. See also: afocal photography, film format, secret photography, photographic lens design, Barlow lens, zoom lens, references. External links, information on catadioptric mirror lenses, further clarification. Why Telephoto? 3-part series on cheap super telephoto lenses, Stanford University CS 178 interactive flasher plates showing how a telephoto zoom lens works.